Good morning. So you know this is the cloud room, right? This is not any of the AI stuff. I hope you're here because the other ones were full, or you really want to hear about cloud? Okay, good. Anyway, very quickly about myself. So my name is Renalias. It's a long story. I'm a Spaniard living in Finland, working all over Europe with Accenture now for 17 years. And what I'd like to do today is to talk to you a bit about my experience doing cloud transformations. So over the years at Accenture now, for at least the last 8 to 10, I've got involved doing cloud and cloud transformations. And throughout that time, we've seen things that worked, things that didn't work, things that we could have done better. And what I'd like to do today is tell you a bit more about all of those things. Because, cloud, we've all seen those demos, right? And you can go and ask Copilot, please build me some Terraform code, and you can be deploying something in 5 minutes, literally. But then it's a lot harder to actually take that and expand to an enterprise, to a company. It's a lot harder to take an application portfolio in its entirety and push it to cloud. There's a lot more things we need to consider beyond the very nice 5-10 minute demos with Copilot or Gemini or whatever you call it. So the idea is let me walk you through some of these things. And as I said there, this is all very opinionated. You may or may not disagree with what I'm saying, but I'm the one standing here and you're not, so just deal with it. And then opinions and failures are my own. And my employer may or may not agree with them, but again, I'm here and they're not, so let's just deal with that. So what do we do in cloud transformation? So I'm part of a group that does this for a living. We've done this now for many years. We get involved sometimes with the strategy. So the vision, the roadmap, the North Star, the business case also is something we do a lot of it. Going to cloud, will it make sense for my enterprise? We get involved with the cloud platform, meaning the architecture, the networking, the security. So making sure that, beyond the 5-minute demo, I can stand up an entire cloud for my company and run it efficiently. We get involved also with the architecture itself. So things like making sure we design compliant, scalable, consumable services for my application in the cloud. We get involved also in the work around taking those workloads to cloud, from small ones, and we're doing hundreds, thousands of them, all the way to taking things like, entire SAP monsters to the cloud. It's a whole different story. And then, it's not my favorite topic, but we also get involved with governance, because the cloud needs to be, unfortunately, governed. It's not easy to have 300 teams, 400 teams, all deploying things to cloud. You need to actually put things in place for that to work. So we're going to cover a lot of this, and there's a lot of ground to cover, I can tell you. I'm using an analogy from a movie from 1966. I think 90% of the room here doesn't even know what the movie is, but anyway, the idea is that I'm going to structure things around the good, the bad, and the ugly. The good is the things that work well. The bad is things that went really nasty, and the ugly is things you should be aware of. And I'm going to use these dudes. At least this one you should know, right? What is he now? Almost 100 years old, this guy? Anyway, so first things first. In the good, I will not go into, we'll cover a lot of topics. We're not going to go into much detail in any of them, but my idea is to share a bit about what went wrong and some of the challenges we faced. So starting with the architecture itself. And I like to call this architecture for the 98%, because unless you're a big tech company, when you go to the cloud, you're just going to the cloud, there is no need for you to reinvent anything. Most of the cloud vendors have frameworks, whether it's the cloud adoption framework or the wall architecture framework. They will walk you through the right questions, or they'll ask you to make the right decision, they'll give you the right options. So at the end of the day, my message is don't reinvent anything. It's just there. You don't even need Accenture, you don't need anybody to go through that. The models are public and they work really well. And my experience, I've used them 100% of the time. So there's been a scenario where we then use a reference framework from a vendor, so they work well. One of the key questions that will come up in that discussion or in that design for the architecture is then the networking model, which we typically select the hub and spoke. And hub and spoke, in our experience, works well. The idea, and again, I'm not going to cover hub and spoke because it would be a concept for an entire session by itself, but the idea is we have a hub with the common services, maybe the firewall, maybe the VPN gateways, express routes, direct connects, whatever you want to call it, to your other infrastructure. And then you have the spokes where you have your workloads for the application teams, for the products, for the businesses. Hub and spoke, in our experience, scales well for an enterprise. We have cases with 300, 400, 500 spokes for different teams. It works well, it scales well, and it works from a governance standpoint, it's actually great. There's a couple of things to consider when we go to the hub and spoke model. A hub becomes a single point of failure. So at the moment we have centralized components, then they can fail. And if those components are in the hub and something fails, then you have a single point of failure in the hub itself. We've had sometimes issues with the firewall because suddenly you have a firewall in the hub and suddenly you can happen, screw up a rule. You have a lot of landing zones, a lot of spokes affected by any mistake in the hub. The hub can also become a bottleneck. I didn't mention at the beginning, my experience is mostly with Azure. And there's an interesting aspect of Azure where the firewall, if you use a standard firewall, it only supports connections up to 1.5 gigabits per sec, which is quite a lot. But sometimes it's not enough for heavy applications. So suddenly if you have a lot of traffic going through an Azure firewall in a hub, suddenly it's not the hub becoming the bottleneck, but it's one of the components that you deploy centrally that may not be able to handle all of the load you need to run. So then you need to go into a bigger hub, which is then in Azure the next tier. A hub might lead to additional latency because it's more hops. But at the end of the day, so going back to the initial message of the slide, hub and spoke works well, but there will be cases where you still need to do direct connectivity. And in those cases, the architecture with the hub and spoke will allow you to connect specific landing zones, peer them, if you have to for specific types of traffic. In any case, there shouldn't be any need for anyone to reinvent anything else that is not hub and spoke based on the typical architecture references that you get from the vendors. Moving on the other hand, so we have the central part, then we have the landing zones. The landing zones is a concept. I'm assuming you're somewhat familiar with the landing zone, is where we put the workloads. And you will eventually map these to some sort of organizational structure on your side, maybe one landing zone per team, one landing zone per app, one landing zone per business, or a combination of this. That works well. We recommend to keep them as small as logically possible, because they're also the means of a level of segregation. So different things in different landing zones, even in different subscriptions, they keep separate from each other. So then you don't mix things in your landing zones. In our experience, something that worked well is designing what we call landing zone archetypes, landing zone models, because typically you'll design a landing zone that is sufficient for, let's say, 80% of your apps. So that any shitty two-tier, three-tier business application with a front end and a middle tier and database, it will fit fine. But then you might bump into things like, well, I need an external party to access my landing zone. So okay, maybe you need a different model for that. Maybe you'll deploy, SAP is one of my favorite monsters. If you need to deploy SAP in your landing zones, SAP is very special, needs its own thing. Commercial off-the-shelf software. You'll find all sorts of variations that, you have a good landing zone model, it covers 80%. Bear in mind, for the remaining 20% of your apps, you might need to design different landing zone models, but that's part of the work. And then something where we've had some issues in the past is with the DR back, so the access control to the landing zones. Specifically, I mentioned a minute ago, right, things like vendors accessing these things. And also, we'll come back to this later, the whole you build it, you run it, where in some cases, development teams want to do everything, and in some cases, you'll have maybe an ops and IT team or an IT team supporting. That is something that also need to account for in the landing zone models. In any case, the message is landing zones connected to the hub and spoke. That works totally fine. Think about when you design them, the different sort of applications that you might need to run, because you will have specific flavors of landing zones. And the point is, create models, because if you start to have 100 landing zones with 100 different variations each, it's actually very hard to govern. And as I said before, governance is not fun, but something we need to consider when we do these things. Now, a favorite of mine, the service catalog. And service catalog is not a new concept. We've done service catalogs for decades. I'm referring here to service catalog as a, in my experience, for me, it's been a cornerstone of a cloud transformation. A service catalog, in the most simple way of explaining it, is a list of services you provide to teams running in the cloud. And the idea is that for us, it's been a tool to communicate to teams going to the cloud. Because on one hand, we have the infrastructure, we have the hub and spoke, but the cloud itself is empty, right? So at some point, you will put their applications, but then applications will need databases, load balancers, API gateways, they'll need persistence, they need caches, they need all sorts of things. With We've been very successful in my projects using a service catalog to communicate from the cloud teams, from the governance teams towards the consumer of the cloud, what is available in the cloud, what is available, what is supported, what are the features that are provided. If it's in the catalog, it will mean it's actually compliant from a security standpoint, and also how they can be used. And ultimately, we use the catalog to help teams decide, first of all, if they're missing a service that they need for the applications and it's not in the cloud, then it means wait, because we don't have that service yet. But on the other hand, we also help them understand what is it that they can use and how they can best leverage these things. I'll go a little deeper. This is from a real project, actually. I couldn't show everything, but you get the point. We actually have one of these models, and this is even a small one. For every cloud where we are, we have one of these models with about a gazillion boxes that help teams understand when they go to Azure or Google or whatever, what is it that they can consume. Because what in my experience, what's helped in cloud transformations is not, the cloud shouldn't be a free-for-all where you can just go and deploy things, no control. With a service catalog from a governance standpoint, see what I'm doing? I keep going back to governance, right? So from a governance standpoint, we communicate what's available, what can be used, where does it run. Sometimes you may be in Azure and you can consume, say, Postgres on Azure, but you might also be consuming, in one of our clients, we're using Mongo Atlas, which is actually on a SaaS. So we can also tell, look, if you want to use a document database, it's Mongo, but it's actually a SaaS, but it's in the catalog. Teams, the consumers of the cloud, also know that if a service is in the catalog, it's standard, it's compliant, it has all of the requirements built in, the tagging, for reporting. It has, I'll come back to this, but it has all of the day one and day two operations built in. So the idea is how we can also communicate to teams all of these things. In our case, our teams know that if a service in the catalog, it's supported 8x5 or 24/7. They know we have people behind these services to support them in case they have questions. We have owners for each one of these things. And then they also know that about 95% of the services have automation support. And I'll come back to this later, but in the form of Terraform and Terraform modules. So from a delivery, from a transformation standpoint, we use this to communicate what we have. From a governance standpoint, we use this to say, you can consume this and nothing else, but they can consume other things, but then it's more of an exceptional process. And it's worked well for us to orchestrate the thing, to the point that I'm being quite bullish about it. You should be thankful, teams should be thankful that we provide them with the service catalog, for the sense that communication, I can't stress that enough. You know what you can consume and it's there. From an operational support, they know who they can go to help. We use the service catalog also to communicate the roadmap, because sometimes the services that we provide them, we provide new features, new releases, so they know when every service will become available and with which features. There's also an entry point from a governance standpoint, there's an entry point to a service catalog in which they can request additional services to implement. And ultimately, it's a tool for us to really kind of orchestrate and communicate and govern what teams, ultimately what teams can and cannot do. There's a couple of pitfalls I'm highlighting here in the slide. There is a bit of a risk that we position the service catalog as, well, if it's not in the catalog, you can't use it. And you can only use what I'm telling you to use. That's not the case. We need to find some common ground between a level of governance and control versus allowing still some of the flexibility and agility that the cloud gives to the teams if they want to use something else. And there's a nice term there, cloud custodian, meaning the teams owning the service in the catalog shouldn't be the ones that say, yeah, it's either my way or the highway, take it or leave it, there's nothing else. There needs to be a bit of a balance there. But ultimately, project where I've been with the service catalog, it's been a great tool for us in terms of communication, governance, compliance, and consistency for the teams. I'll come back to this as we move into automation. And automation is always fun, especially in the cloud, because you have to have automation nowadays, right? Every demo, every documentation, every YouTube talk about the cloud and IIC, it's about doing some automation in the cloud, preferably using some kind of IIC form. Before I dive any deeper, there's a couple things. So in terms of tooling, it's one of those great religious battles, right? Should we use Bicep? Should we use Terraform? Should we use Deployment Manager? Should we use CDK? Should we use Pulumi if you like doing more code? I don't care. I don't give a shit. Pick a tool. They all work. I'm very happy with Terraform Enterprise. I just thought I might give them a quick hat tip because it works well. It has support for running as part of an enterprise. They have a registry. They will keep your workspaces also in their service, especially if you use the enterprise or the cloud flavor. But in the end, just pick one. The important things in the cloud is, in terms of automation, is that it works. In my opinion and in my experience, it can scale to large number of teams deploying hundreds of thousands of resources per day with hundreds of pipeline runs, so it works well. However, keep in mind that it's easy to automate something and just say, yeah, I can deploy something, I can delete something, fine. We'll come back to these, but things like day two are actually quite hard. Patching, upgrading, versioning, there's a security fix we need to roll out immediately. How the hell do I now roll this out without affecting my running stuff? So this is something to keep in mind. And the next one I'm going to go in the next slide is there's a tendency of some zealot teams and say, let's automate everything. Let's automate all the things. We've also found that it's not the case. And to solve that, this is actually from a real project. We developed, I was thinking of a fancy name, so I called it consumer-centric automation. But in reality, it's something we did to structure, what are the key things we typically had to automate in this project, which in our case were 6. At the bottom, we had the automation of all of the core infrastructure, the landing zones, the spokes, the hubs, and so on. On the top, we had actually the landing zones themselves, where teams could maybe change the subnet layout, so provision more subnets and sort of thing. Then we had the managed services, meaning all of the things teams can consume from the cloud themselves natively, and they get them as their own instances. Then we had the shared services, which is shared Kubernetes clusters or shared Oracle clusters or that sort of thing, where automation is a little different because it's actually a shared service, it's not an individual instance. And then we had the custom services that sometimes we need to build when the cloud doesn't support what we need. So what we did is for each one of these, we figured out who is the owner, because ultimately they will be responsible for developing the automation. We also figure out who is the consumer. And in a consumer-centric model, the idea is that you design for the consumer, but also keeping in mind their use cases and keeping in mind how often this actually has to change. So for example, the landing zone stuff, the teams will change these like once every 6 months. They provision it once, they leave it there. So we didn't really spend a lot of effort automating all of this. It's automated, but it's not pretty. But then we spent a lot more time on the upper layers, on the shared services, right? We provide good automation to the team so that as a product team, you could really provision an Oracle schema rather quickly. We provided them really nice modules, Terraform modules for provisioning managed services with all of the operations already supported for them, all of the tagging, all of the policies, all the guardrails, everything is in there. So we spent a lot more time where it made sense, because it didn't make sense to really automate everything, which is something I've seen, again, some really kind of strict religious teams about the automation. But it works, and with this model, we're actually very successful. We were able to deliver very automation for teams, but again, only where it really mattered, and only where it actually made a difference for the teams consuming it. But the key thing here is we thought about it from a consumer standpoint. Right? So especially when the consumer is a team, an application team, but you want them to be fast and do things quickly, that's where we focused our efforts. So that's for the good. So let's move on to Mr. Bad. Automation, I told you it's a fun topic. Automation works at scale, but there's a few challenges. I already hinted about some of these. And there were a couple of them that, in my book, they have nothing to do with technology itself. It was more to do with the people not being very receptive. That was a bit surprising to me as a technology guy. We found 3 types of teams or people in an enterprise, typically. Some teams, when you talk about automation in clouds, we want automation, we like it, we want it, and we know what to do and how to do it. Great. Then we found some teams that really want automation, but they have no idea what they're doing. And then we found teams that they don't know automation and they don't give a shit about it either, which to me was very surprising. I was like, dudes, look, it's nice. You can run some IAC and you'll be in the cloud in no time. Yeah, but we don't care. Our application is deployed once a year, if you're lucky. Okay, maybe then, no, exactly. It's funny. It was funny to me too, but then I realized that these are application teams, especially when we look beyond the traditional fancy serverless Lambda-based app that most of us probably here deploy. There's a lot of There's a lot of shit in an enterprise. Shit that gets deployed once every 2 years, every 1 year, right? So things that, it doesn't make sense for a lot of these teams to even bother with any of these because they'll never use it. And that's something that it was an interesting lesson, but we were able to work with it. And I'll come back when I go to the right-hand side of the slide to talk about how we help these teams. But ultimately, from a readiness and kind of do we want to do this point of view, we found that, not everyone is actually very interested in this. Some teams, as I said before, some teams were mature. They had used cloud before, maybe a little bit under the table, so they were able to use Terraform and whatnot. But then when you roll out automation at scale in these sort of transformation engagements, you'll have to consider that different teams have different levels of understanding. Some teams have different levels of interest. So what we did is, obviously, we trained everyone. Everyone had to be trained with Terraform to some extent to understand even what they're doing, because again, it is to go to Copilot and just copy-paste some code, and you'll be up and running in Azure in no time, or Amazon. But there's a big gap from going there to actually putting production-level workloads using Copilot stuff. That's a different story, right? So we train everyone. And then a pattern that can also become an anti-pattern if you're not careful is sometimes we've stood up Cloud Center of Excellence teams that actually go and help the teams that have a lower level of maturity, or those teams that have no interest. And CCOEs, they will work well to some extent because they cannot scale. Unless you have a CCOE with like 1,000 people, you will not be able to support an enterprise with 200 to 300 teams in 200 to 300 landing zones. So be aware that a Cloud Center of Excellence is a good place to start and a good place to sort of to grow the cloud in an enterprise, but it needs to be a temporary measure, right? So do not rely on a Cloud Center of Excellence for the long term to help you with adoption. Moving on, day two. I talked about it before, and day two is always a pain. Let's just face it, right? Suddenly you're running a service, oh shit, there's a vulnerability in the latest, Postgres, oh shit, you have 1,000 database to update to the latest one, otherwise you're in deep shit with your CISO. Right, I mean, we don't want to run vulnerable stuff in the cloud. Patching, version upgrade, suddenly a resource is insecure, or someone updated the policies and suddenly my resource is non-compliant and I need to update something else. Sometimes performance issues, right? Maybe something isn't going well and you need to start tuning and iterating through many parameters until you get it right. All of these things will require that you actually have day two. And in an enterprise where you're doing heavy automation, day two is just, it's when 95% of your effort, automation effort is going to go. Provisioning is easy, day two is a real pain. I don't have a silver bullet for it. That I'm really sorry. But I wanted to make sure that it's something that you keep in mind, because it will take time, it will be difficult. There are, when you design the automation specifically for situations where in one of my projects we have provided a lot of Terraform modules and so on, we had to spend a significant amount of time ensuring that all of these modules and automation we provide for teams actually supported day two stuff, and that it's supported reliably, because no one wants an actual surprise where suddenly we're on Terraform and we don't look at the apply, at the output of the plan, and suddenly, the resource is gone and recreate it. Shit, right? So we had to spend some time making sure those things were all working well. But surprise, surprise, this was all built as part of the service catalog. So as a team, if you went and consumed my service or the service catalog, you can be sure day two, for at least the 90% of use cases that you will ever need, is supported, right? So that's another way where we can enforce consistency, and by wrapping it in a service catalog with standard services, we can guarantee that day two is actually something we support in there. It just takes a bit of foresight, but there's no silver bullet for this one. Another bad thing is all of these AI talks. You know what they're doing? They're consuming power and they're consuming resources that then you can't use for your Kubernetes and that you can't use for your databases. God damn it. We're seeing now some providers that I will not name facing capacity constraints. And then they say, well, we can't expand our data centers. So suddenly the cloud, as it was sold a few years ago, suddenly it's not so limitless, it's not so scalable anymore. You will face capacity constraints. And if you're lucky, it'll be just for a few minutes or a couple hours. So you can try later and it will work. There will be cases where the constraints will be long-lasting, and maybe they will even tell you, sorry, we can't fix this. It's just we're at capacity. It's a problem, right? Fuck, the cloud is not scalable anymore. What do I do with this? Well, there's nothing you can do. You need to just work around it. And it's going to be a problem because some of my clients, some of my projects, we're deploying production resource, everything needs to be zone redundant. So we deploy 3 copies of every thing. And Kubernetes clusters also, so that I can put one pod 3 times, I need 3 worker nodes in 3 different zones. And suddenly, well, I can't. What do I do, right? Suddenly I cannot deploy my things being highly available and resilient. So now what? Again, coming back to governance, you have to make sure that from a governance standpoint you can deal with it, but also from an architectural standpoint that you can actually deal with the cloud constraints. What we've done is, or what we recommend nowadays is that at least when you talk to your cloud vendors, you have an honest discussion about this. They will tell you if their regions are at capacity or they're getting there, right? And then that should guide you. Maybe you thought you could use 2 regions. Well, actually, maybe you need a 3rd one as a spillover, right? Or maybe just taking to use up front, which means that from an architectural standpoint, if you go for 1 region or 2, make sure you can expand to 3. Even better, have 3 or 4 up front so that you can deal with the capacity constraints. And make sure your teams and your applications can also deploy to multiple regions. Because suddenly, if you want to say you're going to market with a big new release, and suddenly you can provision you're doing A/B rollouts, and suddenly your B part of the rollout can't stand up. There's no capacity. Well, I need to put it somewhere else. Do my pipeline support that? I don't know. You need to make sure that, again, from an architectural and governance standpoint, you fit these as guidelines. If this could be an issue to you into your teams, into your governance, and into your cloud strategy. So again, this should be part of the architecture. There's nothing we can do. Microsoft, Google, Amazon, they will continue to scale, but you will face these limits, and it's something we need to deal with it. Another fun one, cloud lock-in. Well, there's a lot of text in there. I believe lock-in is bullshit. There is, first of all, not being locked in is a myth. It's just not possible not to be locked in. Even if you say, I'm going to use Kubernetes as my abstraction layer, well, fuck it. Kubernetes here and Kubernetes there are very different. They all take containers, but they all configured very differently. So I've seen companies that say, we're deploying everything in Kubernetes because we think it will help us getting out of this, and it kind of minimizes lock-in. It helps lower lock-in, but it's just not going to solve it. So typically what I do, you may choose to be whatever you want with your companies, but what I typically do is I push for lock-in doesn't bother me, because if I lock myself in, I can actually get a lot of benefits out of it, specifically around leveraging some of the more differentiating and interesting services out of the cloud. In the end, it's a game of risks. You need to pick what's important to you. If you're more towards innovation, time to market, flexibility, and all of that, then good, lock yourself in. If you need to actually, for example, the ability to shop around. I understand some companies do this for the ability to shop around. So if everything is a container and everything on Kubernetes, it means I can kind of okay-ish put things wherever it's cheaper to run them, fine. But then that needs to be very conscious choice, balanced, again, some of the stuff you're missing out, right? And again, this would be a topic that we could talk about for days if you want it, but lock-in is an interesting topic. I tend to fall on the side of I'm locked in because I get a lot out of it. Otherwise, I would just be running the cloud as someone else's very basic data center. And another fun one, just to finish the bad, because I'm running out of time. Something we always do in the cloud is estimating the cost, but goddamn, is this hard sometimes. So typically, any good governance process or architecture process to go to the cloud will have you estimate your costs up front. What is this going to cost me, right? What I found is that it's difficult, right? And most of us have done performance management and capacity sizing, so we'll know the volumes, the traffic, the peaks, we'll know the storage needs, we'll know how much it will grow over the years and so on. You will still miss things. Hopefully my checklist helps you a bit. But for example, things like, we had a case where we had a very, very specific security requirement that we sort of thought it's okay, but it actually forced us to go to much more expensive SKUs for a specific service. That thing doubled the cost of what we were rolling out. A couple €100,000, right? it's actually not a small amount. Non-production environments are also a key. You will do your capacity sizing. You'll say, well, I need this many CPUs or whatever you're sizing for your service. And suddenly, well, you actually have 5 environments before production. And okay, well, shit, I forgot about this. What else? There was another case where we had a feature we had to also implement for compliance things, and that thing just killed performance by half. And now I need to size my thing for twice that, and yes, it was twice the price too, right? The tendency to oversize, I'll come back to this later. Ingress and egress and network cost always are an interesting one. And then what I'm calling ancillary and operational components. So we typically forget about the logs, alerting, dashboards, intra-regional traffic. There's a lot of things that typically are not even part of the estimators. Well, they're there, but you need to know that you need to add them to your estimators, right? So it's been interesting. It's been an interesting journey for me, at least, estimating costs for the cloud. All right, and the ugly. So very quickly, cloud sprawl. I'll probably summarize with an example because I'm running out of time. We talked to a team. We're looking at, why is your bill so expensive?
Oscar, just to let you know, we have 5 questions.
Oh wow, thank you. So I'll finish this one. There was a team with a lot of a big bill, and they looked at what are you guys using? Oh, well, why is this thing size like 100 terabytes? Well, no, just in case. Well, the thing was costing 150K a year, and they had 2 of them. Right, so there's a tendency in the cloud, we give them Terraform and automation and all of these things, and suddenly you have a lot of stuff lying around that actually costs a lot of money. So cloud sprawl is definitely something where the cloud can get ugly. But in terms of fixing this, FinOps, familiar with the term, right? It's about being financially responsible on the cloud. The fact that it's easy to provision doesn't mean you can just go and provision whatever you want and keep it lying around. And ultimately, the thing with FinOps is that it can get very ugly if you don't do any sort of cost management. And the interesting thing about FinOps, just to get to the point, FinOps has 3 basic parts. It's cost avoidance. So let's make sure we don't design expensive shit. Cost reporting. Let's make sure that if I actually ended up designing expensive stuff, at least I can see what it's costing. And then cost optimization, which is, sorry, I design expensive shit. Can I optimize it, right? We have a model. This is one of the ones that we have at Accenture, but just to give you a few highlights of what it covers. So on the avoidance side, the key one for me is that teams need to be cost conscious when designing stuff. And I said a minute ago, cost estimating is hard, but it just needs to be done because it's a key for it. Providing them with the right guidelines to make sure they design in a cost-efficient manner, it's essential for it. Reporting is easy. Let's make sure you have some good tagging, and all of the CSPs have really nice dashboarding tools to look at the cost, and then at least show back you should do so that teams at least see what's costing them, right? And then cost optimization, which is more about right sizing. The good thing is in the cloud, there's always new services coming out, new SKUs, cheaper SKUs that allow you more flexibility for the scaling. So having some continuous optimization of what's running is good through right sizing. And then you can also adopt things like scaling and also cost-aware development. So this is not so much at the info level, but at the application level in terms of being cost-conscious. And another one, just to getting close to the end. So the expectations, I didn't know what to call it, but I get this all the time. You start a cloud project and you say, well, we're going to roll this out. And then you say, well, it will take us 6 months. And then you say, but we're in the cloud. Why is it taking so long? You do automation and you do IIC. Why is it taking so long? The thing with the cloud is that I don't think it's any faster, per se, to deploy things all the time. So my experience is that making sure things are scalable, operable, well-governed, compliant, where we did proper FinOps all the way, it will take time that sometimes can be comparable to not doing it in the cloud. There will be other benefits later by being in the cloud, but to me, being fast for the sake of, I'm in the cloud, it's not going to work. And then there's multi-cloud, but I think we're running out of time. Multi-cloud, being on one cloud is difficult. Do you really want to be in 2? It's really hard. It's really hard. And unless you have really good governance, really good tools, really good processes, it will just make matters worse. And I do understand why some companies want to be in the cloud, right? Because of cost, because they want to shop around, because they got a better deal from the vendor, because they want to run some workloads here, some workloads there. but it will make things really hard. So my message, to keep it short, is be very, very careful with going to more than one cloud, because it will make things very difficult if you're not ready for it from an architectural, operations, governance, and technology standpoint. If you're ready to be multi-cloud, and this is the last one I have for today, is the workload placement. And this could be, again, the subject of 10 sessions like this, but the idea is if you're in multiple clouds, many times you will need to figure out what goes where. Something I've been working on quite extensively for the last few months is on workload placement. So given a workload, look at the characteristics and a number of criteria, and then see where it needs to go. I'm going to go through some questions, so I'm not going to go into detail for any of these anymore, but it's an essential tool for those of you who need to be multi-cloud, and will help you then define what goes where in the context of your multiple clouds. I'll address some of the questions.
Has responded one of the questions. Are your customers using multi-cloud architecture? How are you addressing these needs?
Yeah, they are. And are you really sure you want to be in two clouds? Shut up.
Okay, next one. Are your customers concerned about vendor lock-in in the cloud environment? Are you also dealing with the cloud-to-cloud migrations?
So vendor lock-in comes up every now and then, yes. Some clients are a bit concerned with it. Some clients are not. And if they're concerned with it, then you will design for it to avoid it. But then be aware it will lock you out of some really interesting services, right? At the end of the day, if you're in Amazon just to run Kubernetes containers, what's the point? Right? You're not gaining anything, really. So.
Yeah. And I think this is the last question that we have time for. What's the trend? How real and big is the repatriation from cloud back to ground?
Well, it's coming back, yes. No, it's not very big yet, but it's coming. It's coming. Just in time for Accenture to sell you guys cloud exit strategies. So we got you all there to cloud. Now let us help you get out of the cloud. So, but it's coming. It's going to be something. In some industries like financial services, it's already a big thing. Some others are getting into it, and it's going to be something that needs to be considered. Yes.
We just ran out of time, so
yes.
I think we just.
Very good.
Thank you very much,
you.
Oscar. Thank you.